Okay, so this is the seventh problem. Yeah, I think the seventh problem in the grind 75. This one is called valid anagram, and we're given 15 minutes, so we'll start now. Okay, so given two strings S and T, return true if T is an anagram of S and false otherwise. So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Okay, so just so we get the order right, if T is an anagram of S, okay, um, let's see. So the first thing that comes to mind, actually no, yeah, that should work. So, okay, um, yeah, so I'm not, okay, so this is what I'm thinking. So basically I mean, okay, so first off, the order doesn't really matter. We could look at one string or we could look at the other string. All we want to see is that the exact characters used in one string are also used in the other string. So all we care about is character and count. So I'm actually going to write that down. All we care about is character and count. Okay, so we could, let's say, so I'm thinking we'd iterate through, say, S, and we would add each letter to a hash map, and we would increment the count of that letter. So I'm just trying to think of, so when we have a hash map, we can add a character to it, and we would obviously make its value 1. Yeah, okay. So this is what we would do. So, um, so if contains is false for that character, because for example, there's multiple A's here, right? Say we get to the second A, or okay, so sorry. So for the first A, contains would be false, right? So what we would do is um, we would put, for hash maps, it's put, I believe. Add, put, or for stacks, it's put. Push, pop, put. No, yeah, it's put. Okay. We would put the letter, and then we would put the count. Um, in this case, it would be A. Um, else, so if it's already there, then we would say there might be a better way to do this for hash maps, but we would say something like put that letter, and we would do get, is it put or add? Jeez. Okay, so we would get that letter, and we would +1 like that. Okay. Um. Okay. Yeah. I mean, I don't know why I'm stressing about the syntax right here, but um, I think that's pretty much all there is to it. Let's just go through the logic again. So I guess for one, if they're not the same length, then we can immediately terminate. So check caps lock, check if same length. I don't know why I like to do that so much, but anyways, yeah. So basically, the runtime of this algorithm is going to be O of S plus T, where S represents the length of the string S and T represents the length of the string T, because we're going to iterate through all of S and add it to a hash map. And then we're going to iterate through T and compare it to each item in the hash map. I mean, another way we could do it is to add both of them to hash maps in the same way and then just do an equals between the hash maps, which might actually make for cleaner code because we could write the same function or just one function to do the same thing. However, that means we would always be hitting the worst case time every time because we would always make a hash map of one string and then the other. Whereas if we were to just make a hash map of one and then iterate through this value, okay, let me see. Yeah, so that would be a little bit faster. And so actually, when we iterate through the second one, what we're going to do, or the way I'm going to do it, is so when iterate through second string, decrement value in hash map. Okay. We'll have to check. So if the value is ever 0, then if the value is 0 and then we try to decrement, then we know that something's off, so we should return false. So I think we actually yeah, let's go through the implementation because I think things will work themselves out once we have the logic. I mean, the logic is there, but we need to flesh it out in code. So okay, so first off, we're going to do a check. So if s.length does not equal t.length, then we will return false. Okay. Otherwise, we could, yeah, we're not going to do another function, sorry. We're just going to take the first string and we're going to add it to a hash map. And so first we're going to make that hash map, and what it's going to be is, I guess we can do characters. Yeah, because it seems like the best way in Java, at least, to iterate over a string is to do to-char array. So yeah, so we're going to do character and integer, and we're going to set that, or first of all, we're going to make it equal to, we'll just call it scounts. And we'll set it equal to just a new hash map. Its dynamic type will be the same as its static type, and it will be empty for now. And we'll say for character C in s.toChar array, where toChar array is a built-in string method in Java, what are we going to do? We are going to check if it contains. If scounts.contains C, then actually, if this is false, well, it doesn't really matter. If it contains C, then we are going to, I believe it's put scounts dot put, what is it? C, and then we're going to want to just put the value at 1, or actually no. We're going to want to do scounts dot get C plus 1. Yeah, that's right. Else, we're just going to do scounts dot put C and 1. And just really quick, let me make sure that puts is the correct, or put is the correct method for the hash map. Yes, so put is for hash maps, add is for array lists, I'm pretty sure. So going back to this problem, we're going to add each character, add the counts. Let's see. So that should take care of itself. Now we're going to want to iterate through the other string and make sure that its counts match. So basically, I think what I want to do is if we encounter, so for each character, we are going to see if it is contained in the hash map. If that's the case, then we're going to decrement the value. If the value hits 0, then we're going to remove it from the hash map. And basically what we want to check is if the hash map is empty at the very end, because that means that all the characters had the same counts across both strings. So just to iterate through second string. Oh geez, what did I say? Decrement value in hash map. If 0, remove. Check if hash map is empty. Okay, so we're going to say in this other for loop, I'll use x now. So for char x in t dot to, or yes, t dot to char array, what we're going to do is so sorry, yeah. So we're going to get the, let's just check if it contains. So we're going to say if s dot contains, or s counts dot contains x, then we're going to do s dot, or sorry, s counts dot get x. So what we actually want to do is set it to 1, or decrement the value. So we're going to say, I'm sure there's another way to do it, a simpler way, but these are the only methods I know for hash maps. So what I'm going to do is s, my count is up, but we were pretty close, so I'm just going to push through. So we're going to do scounts dot, or scounts, let's see, dot put x. I'm sure, I think there's a word that's like update or something like that. but this is what we're going to do. Let's make sure it's scounts. Okay. This might be a bit messy, but if scounts dot get x is equal to 0, then we're going to want to return false. Not return false, actually. We're just going to want to remove it. I think scounts dot remove x. Okay. Seems like everything we have to do. And then for the very end, what we're going to return is scounts dot is empty. Okay, let me just look at my notes and make sure we didn't miss anything. 0 remove. Yeah. Okay, so quick run through. If this is just a check at the very beginning. If the lengths don't match, then we can automatically return false. We're going to create a hash map with characters as keys and integers as values, and that is actually spelled wrong. Integer. And then we're going to do for each character in the string converted to a character array, we're going to see if our hash map already has that character, then we're going to increment the existing value. Otherwise, we're going to put it into the hash map. And once we've properly added each character and its counts from the first string into the hash map, we are then going to iterate over the second string and decrement accordingly. So yes, for each character, this time x for string t, if it is in the hash map, then we're going to decrement that value by 1. And if the value is now 0, then we want to remove it. The value will always be at least 1 to start with, so we don't have to worry about it being 0 at the get-go. And basically, the hash map should be empty at the end, because we should have removed characters, every character in the array by running down its count. And so that seems right to me, other than potential syntactical errors or just anything misspelled, that should be right. So let's see if that works. Line 11. Dot contains. So maybe there isn't a contains operation for one second, let me see. Okay, so I was just looking at my notes there really quick. It's contains key and contains value. So that's where I messed up. Okay, I gotta remember that for hash maps. Okay, let's run the code again. Let's see. Really should be okay now. Okay, I'm going to submit. Hopefully everything is in order. And all right, we succeeded. Yeah, so just a little syntactical hiccup there. That is something that I do need to work on, straightening out the different names of methods across the different data structures. And yeah, so this will pretty much be the solution, but we'll talk about it a little bit more in the next video.